Okay, so we just have to restart the system. So object constraint language is a textual language for describing the constraints in the UML model. That's in addition to the graphical diagrams. So every OCR constraint must correspond to a class diagram. It doesn't exist on its own. So here's the general syntax where you have context, that is where you start from, and then an invariant. So here it says within the account.
Sorry.
Yes.
Last time we have loaded the logging associate class with many slides. Sorry.
Association. Oh, I see. Okay. Sorry. 60. I think it's 67 or 66, right? Yeah. Okay. Sorry, my mistake. Okay, so let's start from from 61, just to do a short review. So yeah, so association. Person and company, these are two classes associated with a works for association. So this arrow here means the direction. So a person works for a company, not the other way around. You have role names to indicate which role each class plays in the association. So a person plays the role of employee, while a company plays the role of employer. Role names can be used to navigate the association. That is, if you say person dot employer, it navigates from person to the employer of the person by traversing this link from person to company. So this allows you to navigate. So in this case, the two role names are optional. That is, it's obvious which one is the employee, which one is the employer. But in this case, the role names are really necessary because if you don't have the boss or worker role names, you don't know which one is the boss, which one is the worker. So here, John and Frank are related as with the managers association, but who manages who? That's why you need to add the role names to indicate who is the manager. So it's necessary to use role names when an association relates objects from the same class. So this association relates two objects both in the person class. So notice the difference between association and link. Association is at the class level, while a link is between objects. So this person self-association, it doesn't mean that a person is his own boss. It means that one person is the boss of another person. So when mapped onto the objects, these two are always two different people. Even though in the class diagram, it's kind of like a self-link because this relates to two objects of the same class, but not the same object. So association class is sometimes necessary because so for this association, the student enrolls in a course. You have many links between objects for this enrolls in association between classes. Then the question is, where do you put the grade of the student course pair? So in the previous examples where you have managers association, these associations don't have attributes, right? A person is another person's boss, and that's the end of it. You don't have any additional attributes. But here you do have this grade attribute. Therefore, we first discuss a few possibilities which are really not good to bring out the right solution. So the first solution is to use many attributes for grade and pull them into the student class. So immediately you see the problem. You don't know how many courses the student is going to take for his entire stay at university. So how many attributes do you want to put in there? Or you can put it into the course where each course has a collection of grades, one for each student. Then how many grades attributes do you need? Every semester you have a different number of students taking a course. So of course you can solve this problem by putting the maximum number of attributes. Say a student can take a maximum of 40 courses just to be safe. Then many of the grades will be invalid. So that's a solution, but it's a really ugly solution. So, or a slightly better solution is to have a multi-valued attribute that is use an array of grades instead of many grade attributes. Then you don't know which grade corresponds to which course. So if you use many attributes, at least you can name the grades, right? Comp211 grade, Comp252 grade. But here you can't even name them. So if you put them in the course, again you have the same problem. Whose grade is it? So here's the solution. Right solution is to have a erosion as a separate class connected to the association by a dotted line, not a solid line. So this class is not independent from the other student and course classes. Erosion describes the association between student and course. So therefore, if you delete the student or the course class, or if you delete the association, this association class automatically disappears. It's not an independent class. Then the benefit, of course, is to have allows you to have an attribute grade in the association class, so you can place the grades on the for each student course pair. Which is much more reasonable than placing the grade into either the student or the course classes. Or another solution is to have have a separate class that is semester class that sits in the middle of the student and course classes. So a student takes a course taken in some semester is fall 2008, and a course is offered in some semester. So the benefit of this is that now you can associate multiple grades to each student course pair. So why do you want to do that? It is because a student may take a course and fail it, and then he may take it again in the next semester. Therefore, this allows you to enter. Say Marco takes Comp332 for one semester and got a C, and another semester he got an A+. But for the association class, you cannot do that. For each student course pair, there's only one grade. So the separate class approach is more expressive, more powerful. At the same time, you shouldn't use it unless you really need it. So here the semester is really a separate class. It can exist independent of the student and course classes. If you delete the course class, the semester class sits there by itself. But here the enrolls in class is association class, which is dependent on the two main classes. So each semester object must be related to a student and a course. So you can enforce this by adding some multiplicities to each of the end. Say 1, 1 to indicate that a semester object cannot exist. Cannot sit there without it being linked to either a student or a course. But from this diagram now, it's not obvious. From this diagram, you can have three separate classes completely independent from each other, but you can enforce additional constraints on the class diagram for your application. When to associate an attribute with an association. So here's the association person works for a company. Where do you put the salary? So the answer is you need an association class to have an attribute associated with the association. So the association class is only needed for many-to-many associations, like the student-to-course association. For this example, if a person only works for one company, then you can put the salary into the person class. It's not necessary. Well, you can have a association class to store the salary attribute, but it only adds to the complexity, which is really unnecessary. But in the other case, if a person can work for multiple companies, and for each company he draws a salary, then you do need an association class for each person-company pair instead of for each person. So this is the general rule. Only for many-to-many associations, then you need a association class. So this is if it's many-to-one, then you don't need it. So aggregation and composition it describes a part of relationship between one class and another class. So this is a type of association. So it is stronger than the association. So aggregation means that it is this shape here with this empty inside versus the composition, which is has this solid shape with black filled color. So for aggregation, it means that a component consists of some other components as part of it, but this some other component can exist independent of the aggregate object. For example, here a computer has disks. But the disk can exist independent of the computer. You can buy a disk from the store without a computer. So it is aggregation. So we denote this shape here really denotes min card equals 0 and max card equal 1 or star, which means that the minimum cardinality, that is, the minimum cardinality is 0, means that a disk can be associated with 0 computers. that is, a disk can exist independent of a computer. While for a composition, you have main card equal 1, which means that say a course has many course offerings, but the course offering cannot exist independent of the course. If you delete the course object, all the course offerings associated with it are gone. Therefore, the main card is 1. It means that there must be at least one course object if there's to be a course offering object. So by drawing this circle with either a white or a black inside, you implicitly state this main card constraint. So it's a convention. The max card could be 1 or star, which means that you can have a disk can belong to, well, for this case, a disk always belongs to one computer. But for some other cases, something may be owned or contained by multiple parents. So we want to use aggregation and composition. So remember, aggregation and composition are the special cases of association. If you change the aggregation into a regular association without this little shape over there, it's always correct. Because you're changing from a more specific relationship to a more general relationship, but not the other way around. So when you use the part of to describe, when you use aggregation and composition, the test is, would you use the phrase part of to describe the association, or name it someone has something. So not all has associations are aggregations. So for example, I have 2 arms, right? So that's perhaps a composition relationship. But say I have 5 students, then that's not really an aggregation. The students and I are really not a part of a relationship. It's more of an equals relationship. So be very careful. Just because you see the word has or have doesn't mean that it's automatically a aggregation or a composition. So is there an intrinsic asymmetry to the association where one object class is subordinate to the others? So that is a test. So for example, my arms obviously belong to me. It's subordinate to me, but my students, well, they are kind of subordinate to me, but really it's symmetric. It's not, or you can say it both ways. So I have 5 students, or students can say I have a professor as advisor. So it's really a symmetric relationship. So our operations on the whole automatically applied to the part. Then if it's true, then it's composition. Otherwise, it's more likely aggregation. So so for the course and course offering composition relationship, if you delete the course, you automatically delete the course offering. It's a stronger form of relationship. While for the computer and disk example, if you destroy a computer, then the disk can still survive, right? You can take the disk out. So therefore, it is not composition. So are some attribute values propagated from the whole to all or some of the parts? So for example, the course example, if the course gets changed from a 3-credit course into a 4-credit course, the course offering automatically gets changed, the attributes. But for the computer example, the attributes may not propagate directly. So if I raise the price of a computer, it doesn't mean the disk price is also raised. So the composition is really much stronger than aggregation. So decision to use aggregation is a matter of judgment. That is, it's a design decision. So you should you should. So when in doubt, always use association rather than aggregation or composition. So it's never wrong to do that because association is more general. So whether to use association or whether to use aggregation or not really depends on your application. If you see a strong subordinate relationship, then you use aggregation or composition. Otherwise, just use association. So we have discussed several type of relationships. Association, which is more general, most general, describes links among object instances. And there are several others. Generalization relates two classes, relates a more general class, that is a superclass, to a more specific kind of general class, that is subclasses. So this is, say, a bank account is a superclass, while a checking account or savings account is a subclass. So a bank account is a generalization of a checking account, and checking account is a specialization of bank account. So this shape there is this generalization relationship, and dependency relates classes whose behavior or implementation affect other classes. For example, it can relate two versions of the same object at successive times. That is, an object as time goes on, its version may change. So it may go into a new state at a future time, and some of its attributes may change. So the flow dependency can relate to these two versions. So flow and usage are the two variants of the dependency. That is the dotted arrow relationship. Usage means that one class requires another class for its correct functioning. So frequency used to represent implementation relationships, such as code level relationships. That is, say, one class really needs the to call the APIs of another class. So dependency is fairly general, fairly vague relationship. So typically you need to annotate the dependency edge with additional information to say exactly what is the dependency. Otherwise, it's not very clear. So realization relates specification to its implementation. That is, you may have a abstract class with no implementation. All the methods are pure virtual methods. You just have an interface, and then you have a concrete, more concrete implementation class with all the method bodies. Then you can have a realization relationship between these two classes. So we have discussed generalization and association already. So as the course goes on, we'll mention dependency and realization in the future. So don't worry if it seems a little vague to you. So here's a class diagram example. So let's see. So here's the an order has attribute state and delivery address. So you place an order to a merchant. The date records the date you placed it, and you specify delivery address, which contains a bunch of items with an aggregation relationship. So the item has description, picture, and cost, etc. So you can see it's an aggregation relationship because the items can exist independent of the order. And each order must contain at least one item, otherwise it's an empty order. It doesn't make sense. Or it can contain multiple items up to no upper bound. It's a star. So an order is associated with the invoice. That is, the invoice can be for multiple orders. So you may place 5 orders, separate orders, and then you may get one invoice from the merchant to pay the 5 orders as one bill. So invoice is just a bill. So that's why you have $1 star at the order side, but 1 at the invoice side. Each order corresponds to always only one invoice, but each invoice can have 1 or more orders. And account is related to invoice. May have a buy invoice or a sell invoice. So if it's a buyer account, you have a buy invoice. Account can be associated with 0 or more invoices. That is, an account may not be active right now. It may have 0 invoices, or it may have multiple outstanding invoices. And a VIP account is a special type of account represented with this inheritance relationship. That is, the VIP account inherits all the attributes from account with the balance attribute and owner attribute, with additional attribute expiry date. That is, you pay some annual fee to become a VIP, and you have an expiry date at the end of the year. For example, it's incomplete because only some accounts are VIP accounts, others are not VIP accounts. So do you need a separate, say, non-VIP account as another subclass in this class diagram? Then it will be complete, right? Do you need it? Any volunteers? Have a VIP account. How about adding a non-VIP account? Over there also inherits from the account class. What do you think?
No.
Why not?
If those account is not VIP, then other is non-VIP account, right? So it's not necessary to make another.
Yes, exactly. You make a subclass only because you want to add some new attributes or operations. If the subclass is identical to this base class, to the superclass, then it's not necessary to add it. It's redundant. So class diagram can also be used to model runtime software behavior. So this is not really the focus of this course. We focus on static modeling when you use class diagrams. But just to show you, it can be used to model it. Here's the event handler class with the 2 private attributes. You have the minus sign in front of it, which means that they are private. Each event is each event has an ID and has an event handler. So whenever this event ID event happens, the event handler is invoked, and you call this handle request method on the event handler object. So so the source is who sends the event, and the current event ID indicates the event ID. So you can imagine in the handle request implementation, you may do a switch case statement to invoke different code based on the current event ID. And you may have a association from event handler to itself named successor. That is, event handler may invoke another event handler as its successor. So each event really triggers a chain of reactions instead of just a single event handler. And you have a GUI event handler, which is a special event handler for graphical user interface events. So you may have other event handlers for, say, network packets or for other non-GUI events. So the client has this, that is not an association. Remember, the dotted line is a dependency. That's a, for this, it's a usage dependency. That is, the client uses the event handler for its operation. So this is for modeling software programs, while for the previous example it's modeling data. So for this class diagram, it has direct mapping into the database schema. In fact, if you took the database course, the entity relationship diagram is really identical to the class diagram except notation. So there's a one-to-one correspondence between the ER diagram and a class diagram. But for this, it's really modeling runtime dynamic behavior, so it's not, doesn't have a mapping to the database. It's for a different purpose. So here's an example. Car loan example. So here's the application. So a person may work for any number of companies. That is, the person may hold multiple jobs. Persons, companies, or banks may own cars. Car owner ID represents either the person, company, or bank who owns the car. A car may have only one owner. A car loan given by a bank is for the purchase of a car. Only the owner of a bank, the car may obtain a loan on the car. A car may have multiple car loans. So prepare a class diagram in which the OIDs are either deleted or replaced with relationships. So each class really should have a private attribute called OID, object identifiers, to identify each object uniquely among to distinguish it from the other objects. But this attribute should never appear in the conceptual modeling level. That is, you should never explicitly put OID into the class and as an attribute, but it's implicit in all the classes. So you should model any of the OID with relationships. What does this mean? It means that, for example, if you design a database, how do you establish a link between two tables? You provide a common column, right? So if a student has a student ID, and you can and say another table also has a column called student ID, then you can link. You can do SQL queries across the two tables by navigating this by this common column. But in this case, we really use associations in the UML diagram level to represent links between different classes. So here's the first. You draw all the classes first without any of the associations. Then you add them gradually. So person, car loan, company, bank. Each class has a bunch of attributes. So notice that you have these ID attributes. Company has a company ID, bank has a bank ID, car has a vehicle ID, etc. So if this were a database, then you can establish relationships by these common columns or attributes. Say you want to find out which company a person works for. Then what do? You try to match the company ID with the employer ID in the person class. If there's a match, it means the person works for a company, right? Or you can say a bank issues a car loan. So which bank issued a particular car loan? So you try to match the bank ID with the one of the banks to establish this relationship. So that's how you do it in the database with these common attributes. But in the class diagram level, we have better ways of denoting the relationship. We have the association, right? We don't need these IDs. They may be used in the underlying implementation in the database for actual implementation, but right now we are at the conceptual modeling stage. We don't have to care about implementation. We only have to care about how to express the relationships abstractly. So we delete. First of all, the person ID is useless because it is not does not appear in any of the other classes. It is not used for establishing associations. So it's just an internal identifier. We delete that, and we delete the vehicle ID of the car because it is OID. It is not used for associations. Company ID is deleted. Bank ID. So now the employer IDs, they are deleted at the same time. You should add association from person to a company to indicate that to do the job of the employer ID in the first place. The existence of the employer ID is really for this association. Now you just add the association directly. And a car is related to a person from its owner ID and related to a company or bank. Remember, either a person or a company or a bank can own a car. The owner doesn't have to be a person. So if you delete owner ID, you should add 3 associations. So vehicle ID is used to indicate which car is this car loan for. So if you delete that, you should add association from car loan to point to the car. And bank ID, you delete that and then add association between the car loan and the bank. Customer ID, you delete that and add a association between a person, company, and bank. So this is so we should owner type represent whether the car owner is a person, company, or bank. It's not necessary anymore. And customer type and owner type, they both denote whether the owner is the person, company, or bank. But if you add the association from car to person, owner, company, bank, and from car loan to person, owner, bank, person, company, bank, then this type is no longer needed. You can just navigate to the association to see what type the owner is. And then you realize that a bank is just a special company. So you don't really need a separate bank class. You can inherit from company so that you can delete this name attribute from bank because it's an inheritance relationship. So some of the IDs represent associations, like the employer ID really represents association between person and company, but others are merely internal IDs and should not appear at all, like the person ID or vehicle ID. So it's really, you should make the decision based on application knowledge. So here's the initial solution we got. So from the previous analysis, so a bank is a special company. Notice that we deleted the name attribute from the bank, and a car can be owned by a person or a company or a bank. Now the owns association, there are only two. You don't need to draw the association between car and bank anymore because you already have association between the car and the company, and the bank is a special company. It inherits from company, so you automatically have an association between bank and car. So remember, the subclass inherits everything from the superclass, including attributes, operations, and any associations. So a bank can lend a car loan, one or more car loans, and a car may have several car loans associated with it. So so we can generalize again person and company to owner, since both have the same associations and both have an attribute name in common. Therefore, you can make the diagram more concise by generalizing another superclass owner. Then you can move the name attribute to owner. And also, the diagram is much simplified because you only need one association relationship between owner and car, which means that all the person, company, and bank automatically inherit this association. So it says disjoint a complete annotation there, because a person and company class is a disjoint. You can never be a person and a company at the same time. Even if you are a one-person company, they're still two different entities. They're complete because the owner should be either a person or a company. There's no a third choice. So common errors that can be made for this example could be missing classes or associations, extra classes or attributes not specified in the problem statement. So you should stick to what is stated in the problem statement. Do not be creative and add new things to it. Incorrect associations, incorrect use of aggregation. So there's no aggregation in this example. So you may think perhaps a car may consist of multiple car loans. That's a stretch. So a car has 4 wheels. That's obviously aggregation. But a car has several car loans. That's really more of a symmetric relationship. It's not an aggregation. Incorrect use of relationships and redundant associations. So association between any two classes, you should have only one association with the same name. If you have multiple associations, it should be different associations with different names. So missing association names. Association names are optional. They're not required, but it's always a good idea to name them for readability purposes. missing or wrong multiplicities. So the multiplicities, that is 0 dot dot star or 1 dot dot star, these should be always added. Ternary associations are really needed. So it may be necessary for rare cases, but at least for this course, we almost never need ternary associations. Always use binary associations. And higher degree associations are not needed. Incorrect notation. So if some students have taken the database class, you may draw these different pictures with entity relationship notation. These are the same as class diagrams in terms of their meaning, but for this course, we use the class diagram notation, not the entity relationship notation. So that's links and associations. Any questions?
When do we need to put the multiplicity? Only in the association.
Multiplicity always describes the association, right? On either end of the association.
Yeah, like company and brain, there are no multiplicity because they are superclass and gen.
Yeah, because that's not an association.
Okay.
Right? This is inheritance or generalization. Different names, the same thing. So all the others are associations. So composition and aggregation are special types of associations. But inheritance is a different animal. Inheritance is separate. It's not association. Okay? So constraints. We sometimes need additional information on the class diagram to assert assertion about properties of model elements that must be satisfied by the system. So, for example, a preferential savings account whose balance always must be greater than 100,000. So you can write it as this: preferred savings with the attributes account number amount, and a balance with this precondition balance greater than or equal to 100,000. Or you can have this note placed on the class diagram. So this shape here is really unofficial UML notation. It's a little box with a little folded corner. It means that it's like a sticky note. You can place any text inside of it. It doesn't. You can place natural language inside of it. It's very informal. So, so this is a constraint that can be tested as true or false, and it should be enforced by the system implementation. So at this stage, we're doing modeling, so we don't care how you enforce it. If you try to withdraw money so the balance falls below 100,000, the implementation may prevent it by issuing an error or doing something else. We don't care. We only care about the specification right now. So this constraint can be specified in this manner, but it's very informal. So that's why you need a more formal way of expressing the constraints, which we'll discuss as the OCR next. So common constraints. First of all, the multiplicities are constraints already. So country has president. Country has multiplicity 1, which means that every president must be for one and exactly one country. A president has multiplicity star, which means that a country can have 0 or more presidents. A company may have 0 president because it may be in a transition period, for example. So these are already constraints, and then you can add additional constraints such as ordered. It means that you have an ordered list of presidents instead of a set with no ordering. For this case, the order may be chronological. You can list all the presidents in the history of the United States as the ordered list. So subset relationship. So here's the example. A person may serve on 0 or more committees, and every committee must have a chairperson. So you have 2 associations. Member of, person is a member of committee, and chair of, person is the chair of a committee. Notice that you can have a star here, which means that a person can join no committees. And then you have one dot star over there, because a committee can have as members multiple persons, at least one person. Have one over there, it means that a committee always has only one chairperson. So you can have the subset relationship between these 2 associations, which means that the chair must be a member. It obviously makes sense, right? Why would you have a chairperson of a committee who's not even a member of the committee, right? But if you don't have this subset relationship, this class diagram really allows that situation. You can have a person who is a chair but not a member. But by adding this relationship, you prevent that.
It's just dependence.
This is now I think this is different from dependency. This is kind of a loose use of the notation, so it looks like dependency, but this is really a notation for expressing constraints. Yeah. So XOR, that is exclusive OR. So account, a person may have 1 or more bank accounts. A company may have 1 or more bank accounts. So a person always has a personal account. A company always has a business account. Now, by adding this exclusive OR relationship between these 2 associations, it means that a bank account is either a personal account or a business account. You cannot have a hybrid account like both a personal and a business. Doesn't make any sense. So this is really one way of expressing this type of constraint. Another way is that you can have inheritance by having 2 subclasses with the disjoint annotation, right? You have a personal account and a business account as subclasses of account, and you can say disjoint to express the fact that you cannot have intersections between these 2. So there are many ways of doing the same thing. So now we come to OCR. So OCR is a formal language for expressing constraints. So all the previous notations, as I discussed, sometimes can be very informal. You can even add a sticky note to the diagram and use natural language. But OCR allows you to be very precise and very formal. So the notation is that you have a context with an optional name for the context and a class invariant, that is something that is always true of the object at all times, it means it's an invariant. And then pre-post conditions of an operation and name for the constraint and constraint specification, Boolean expression that evaluates true or false. So here's the one example. So context, keyword, and ACC is the is the class name colon preferred savings. So preferred savings is the class name. ACC is the context name. That is, it's really like an object. That is, it's referring to the class. And then you have INV invariant. Everything that follows the INV keyword is the actual constraint. It says account minimum, which is the constraint name, colon ACC.balance greater than equal to 100,000. It means that the any object of the preferred savings class must have an attribute balance that is greater than or equal to 100,000. So this really expresses this same constraint as what we showed earlier with either these two notations. But this is very informal. The OCR formalizes it so that you can you won't have any ambiguities. And furthermore, having a formal language allows you to use formal verification tools to verify these constraints with computers instead of always having a human to understand it. Constraint specification may contain navigation expressions which identify other objects that may be relevant to this constraint. So for this example, there's no navigation, but there will be next. And assertions about the context object or the relationships between the context object and any objects retrieved by the navigation expressions. So for this account balance greater than equal to 100,000, this is an assertion. That is a Boolean expression that evaluates the true or false. This is the assertion about this context object, that is the ACC. There may be assertions about the relationships between the context object and other objects. So we will show some examples next. So navigation, so start from a context object. Use dot notation and class role names to navigate to a local attribute. So that is the example we showed. So here's one example. Within the context post, invariant colon salary greater than 100,000. It means that for every post, the salary is always greater than 100,000. So this is a local attribute. So this is actually a simplified notation. If you look at the previous example, it says the same thing, right? Contact account, and then you have account dot balance greater than equal to 100,000. So you can really simplify it by removing the ACC from here, removing it from here, and removing the constraint name, so that you can get a context preferred savings invariant balance greater than equal to 100,000. So that's this notation. These two are equivalent. It's really a more concise notation if you only have local attributes. You don't have to specify the context name. Although you can do it, it's not wrong, but you can omit it. Or directly related class and indirectly related classes. So here's the example of indirectly related class. So for starting from the contact person, you have the invariant as says the person's employer must be the same as the person's department's division, right? So now this is a double interaction. You navigate from person to department and then from department to division. So we'll show some examples. So employer is a directly related class to person because in the class diagram you have a direct association between these two, but division is an indirectly related class. You got to go through department first. So collections, a navigation expression that returns more than one object returns a collection of which there are the following types. So it may be a set that is result of navigating a single association. So for example, from a professor to navigate to students, you have a professor has many students, you get a set of students. Or you can have an ordered set that is navigating a single ordered association. For example, you navigate from a country to presidents, you may get an ordered set of a list of all the presidents from George Washington, ordered chronologically. Or you can have a bag that is a result of navigating a series of at least two associations with one to many or many to many multiplicity. So what's the difference between a set and a bag? So a bag can contain redundant items. One item may appear twice in the bag, but in the set, each item is always unique. So if you navigate at least two associations, you may reach a object from two different paths, and then you list this object twice in the bag. That's why it's a bag, not a set. So a sequence is a result of navigating a series of at least two associations with one to many or many to many multiplicity. That part is the same as the bag, and one of the associations is ordered. Therefore, this resulting list of items has a ordered relationship. So it's a sequence of items which may have redundancy. That is, one item may appear multiple times in the sequence. So bags are multi-sets that can contain the same object multiple times, obtained from traversing different paths to the object. So this operator arrow indicates the collection operation is being applied. That is, you are returning a collection. So we'll show some examples. So here's one example constraint. Number of employees in every division must be equal to the number of employees in all of its departments. So perhaps we should review the class diagram first. So here's the class diagram. A person works in a department. A division may have multiple departments, and at the same time you have a direct association between the division and the person as the employee-employer relationship. So as you can see, you can navigate from, if the contact is person, that is you're starting from the person class, you can navigate to the division by following this association, or you can navigate to the department by following the works for association, and then from the department to division. or can navigate from person to contract via this association class relationship and then to post. So, for example, if you want to find out how much a person makes as his salary, you can navigate from person to contract and then to post and then look up the salary. So that's the class diagram. Now this is the object. So this is not UML. This is just an informal drawing. So now the person class has 4 objects, and division class has 2 objects. Marketing production department has 2 objects. The marketing division has 2 departments, sales and advertising. The production division has no departments. The association is star as multiplicity on the department end. Therefore, a division can have 0 departments. So, number of employees in every division. So, how do you express that? So, just intuitively first, let's express the OCR later. So, look at marketing division. So you look at you want to find out number of employees. So you navigate the association from division to person, and then the next part of the constraint says it must be equal to the number of employees in all of these departments. So you navigate from division to department. Marketing has 2 departments, and then from department to all the people in the department by navigating the works for association. And then you check if they're the same size. So the formal expression of OCR is context division, because you're starting from the division as your origin of navigation. And then invariant says employee size. So you navigate from division to person by specifying the role name, employee. You can also specify person arrow size. It's the same. When you do navigation, you can specify the target class name or the role name of the association. They're both okay. For the department navigation, you want to navigate from the marketing to the department that belongs to marketing. You follow the part of association. In this case, there's no role name, right? So you just specify the department class name. Department dot staff. Staff is an attribute of the department. And then you invoke the size operation to obtain the sizes of these sets. So, and then you say they are equal. So, so any questions about this OCR constraint?
Actually, what's invariant?
Invariant means that something that never changes. It is a mathematical term for constant truth. That is something that's always true. So never false. So here's another example. Every employee's post is one of a set of posts of that employee's division. So a division may have multiple posts. It may have secretaries, managers, engineers, testers, developers. These are posts. Now, every post is post describe job positions. You may have empty posts. That is, you may have an open position. And a person signs a contract with the division this employee-employer association has this association class contract, and then the contract is for a particular post. So I sign a contract with HKUST for the post of a professor. So that's the relationship. So now we're trying to express the fact that every employee's post is one of a set of posts of that employee's division. So obviously now you should start from an employee, say Sarah, and what's her post? Now you got to navigate twice. First to contract. So let's look at first the latter part of the constraint. So navigate to the division first. Sarah works for marketing. Marketing is her employer, and then from marketing you can see all the posts in marketing. And then you do the other navigation from Sarah to her contract, and contract is for a particular post. So, and then you check if if her post, that is agent, is part of the set of posts in marketing. So agent is part of the set of manager, clerk, and agent. So that's fine. So the constraint is contact person. The invariant is that employer.post so that employer means that really the same as if you say contact Sarah : person, and then Sarah.employer is the same thing. Just omit the context object. And then this is the role name of this association. So you're navigating from person and to the division. Again, you can say division.post instead of employer.post. It's okay too. Includes is this set operator says contract.post. Contract is from the context person navigate to contract, and then from contract to post. So, and then you have this includes relationship, employer's post. The first employer.post returns a set, and then the second contract.post returns one element, one item, and then the set must include the item. So whether it's a set or item depends on whether the association has multiplicity 1 or more. So any questions on this?
Yeah, actually, can I say employee.post instead of employer.post?
No. The reason is that if you want to do navigation from one class to another, you must specify the role name on the other end. So you want to navigate from person to division. You specify the role name of this end, person, employer. You want to navigate from division to person. You specify this end.
So I can use employer or division.
Yes, both are fine. If you have a role name, you can use the role name, or you can use the class name. But for this department and person, you can see that there's a role name here, staff, but no role name here. Role names are optional, remember. So if you want to navigate from department to person, you can use staff or person. But if you want to navigate from person to department, you must use department. There's no role name. So.
And about the include something.
Include is a set operator. That is a keyword in OCR. So you can only use it if the thing on the left of the arrow is a set. Otherwise, it doesn't make sense. So a set includes some other items. Could include a subset or could include a single item. So last example. So the staff of a department are all employees of the division the department belongs to. So it's a mouthful. So now you start from a department, say sales, you navigate to the division that the department belongs to, that is the marketing division, and then navigate to all the employees of the division. And the other is from the department sales to all the staff members within the department by navigating the works for association. And then you say that this set pointed to by the green lines is a subset of the set pointed to by the red lines. So from the department at the context, you say division employee and includes all of the staff by navigating from department to person, right? Because staff is the role name, so you can specify the role name when you do that navigation. So this really says that Larry, Wendy, and Sarah, they all work for sales. And there must be a subset of the employees, Alan, Wendy, Larry, and Sarah, who work for marketing, which contains the sales department. So any questions? Okay, very good. So next Monday, I think it's a public holiday, so I'll see you on Wednesday.